Hello everyone, welcome to the control system. This is part 4 of lecture 7, Transient and Steady State Response Analysis. In this section, we'll discuss definition of transient response specifications. So we have some term like TD, called the time delay, TP, TS, TR, MP, and so on. So we'll talk about this in the next slide. So first is the delay time or time delay. So it's the time for the response to reach half of the final value the very first time. Okay. And some people think differently. For example, if you inject the system in the step response and then it won't rise immediately, right? At some time in the futures, it will start to respond. So that can also consider as the delay in the signal. So let's just stick into the definition. Delay time TD is the time required for the response to reach half of the final value the very first time. The very first time between this one. The very first time it reached TD, half of the final value. And the rise time, TR, is the time required for the response to rise from 10% to 90%, sometimes from 5% to 95%, or 0% to 1% of its final value. It depends on the system. So for undamped second order system, the 0% to 1% rise time is normally used. For overdamped system, the 10% to 90% rise time is commonly used. And the peak time is the time required for the response to reach the first peak of the overshoot. This one, okay? The first peak of the overshoot. And the maximum overshoot, MP, is the maximum peak value of the response curve measured from the unity. If the final steady state value of the response differ from unity, I mean it's not 1, then it is commonly used the maximum percent overshoot. It's defined as this one. Okay? C at the overshoot time minus C infinity over C infinity time 100%. And settling time, TS, is the time required for the response curve to reach and stay within the range about the final values of size specified by absolute percentage of the final value, usually 2 or 5%. 2% is commonly used. And note that not all this specification necessarily apply to any given case. For example, for an undamped system, the term peak time and maximum overshoot do not apply. Okay, and there are a few comments on transient response specifications, except for certain applications where oscillation cannot be tolerated. It is desirable that the transient response be sufficiently fast and be sufficiently damped. And thus, the desirable transient response of the second order system, for the desirable transient response of the second order system, the damping ratio must be between 0.4 to 0.8. Okay, and small value of psi, psi less than 0.4, will yield the excessive overshoot of in the transient response. If psi is very large, not very large, but larger than 0.8, it responds floshlessly. And note that the maximum overshoot and the rise time conflict with each other. Both maximum overshoot and the rise time cannot be made smaller simultaneously. If one of them is made smaller, the other necessarily becomes larger.